All right, hello everyone. I just wanted to kind of go over some details with the Hertzsprung-Russell diagram. This is a diagram that we use in astronomy to categorize stars based on a couple different characteristics. What I tell students is this is basically like a glorified graph, but instead of having just one X and one Y axis piece of information, you've actually got two sets of X information and usually two Y sets of information. In this one, there is not any information over here, but we'll talk about what you will usually see on the other side here momentarily. And the good thing is you can take this diagram and the information can be flipped from top to bottom or left to right, and all the information will change as far as the appearance, but you will still be able to find all the answers you need in this diagram. So a little quick background information. This was developed around 1911 by two scientists, obviously Hertzsprung and Russell. So what you've got down here in the bottom x-axis is surface temperature. Now, this one is measured in Celsius, but you will see some, instead of Celsius, it'll have degrees in Kelvin because you're dealing with a lot of extremely high temperatures, okay? Over on the far left y-axis here, all right, couple things. Absolute brightness, that is also called luminosity. You'll see that sometimes. And then every so often certain diagrams will have the units with this, which is watts per meter squared. Okay, again, absolute brightness and luminosity mean the same thing. Up here at the top, you've got your different colors of stars. Please remember, the bluer stars are the hotter ones, and you can verify that with the surface temperature down here. So, red to red-orange to yellow to white to blue-white, and then finally blue. Now, you will also see this listed obviously by color, but another phrase for that is called spectral class or spectral type. Okay, same thing, just a different set of terminology for classification of stars according to their colors. And again, you can see the different highlighted ones here throughout. These are blue towards the left here, blue-white at the edge, white, yellow. Your red-orange, you can kind of see some right at the line there between that and the red category. So just get familiar with the organization of this chart. Finally, over here, I will tell you, you will see something called, I'm going to turn this a little bit, it's called absolute magnitude, okay? Also known as true brightness. Now, that just measures what it sounds like, the measurement of the brightness of the star, all right? As far as inside the diagram itself, some categorizations of the sizes of stars. You'll see supergiants, and again, those are categorized with this dotted line around in that category. White dwarfs down here, categorized in that section. Giants right here. And then this big section of stars that goes from the bottom right up to the top left, right here, okay? Those are your main sequence stars, which is what our sun is. Now, one other popular star you'll see sometimes, well, you see all the time in the night sky, but people talk about is the North Star, okay? That is a supergiant. So there's some star names in here you can familiarize yourself with. Some of you may have heard them when you talk about just different things in astronomy. Now, I do want to point out one thing. We're going to go back to the spectral class for a moment. Some Hertzsprung-Russell diagrams, you will see letters going across here and solid letters. For example, you'll have like an O here, okay? You'll have a B sort of right here in the middle. Then kind of right here is an A. Then like a F right here. Sometimes you'll get a G in this area here. then we get a K right in here. And then finally we get an M over in this direction here, okay? So, some people always ask, why are these random capital letters going straight across the diagram? Let's go back to the spectral class for a moment, all right? I'm gonna put it down here for you. Spectral class, all right, categories, okay? So O is blue. We're talking about blue stars. B is blue-white stars. Your A is white. F is your yellow-white star. Your G is your yellow stars. K is just true orange. We always like orange. And then your M is your orange-red. So as you can see right here, that's about the general locations you'll see them on all of your diagrams, kind of towards the bottom a little bit and straight across. I put them in the general area, not the exact spots, but just kind of give you the idea of how that looks. Again, you've got a lot of information in this diagram. Don't let that get you bogged down. Just find where everything is, whether it's surface temperature, luminosity or absolute brightness, color spectral class, or your absolute magnitude, and then just work across or up and down depending upon what you're looking for. And your sizes of stars, those classifications are in the diagram themselves, okay? I always tell people, first thing you need to figure out is what's your surface temperature measured in? Is it Kelvin or Celsius? Once you do that, everything else is pretty self-explanatory. The one last thing I would tell you about your absolute brightness, some diagrams have the actual number measurements on this y-axis. You'll see those, I'm gonna pull this down here for a moment, okay? They're measured with exponents. So if you have 10 to the second power, because you're dealing with a tremendous amount of brightness with your stars, so you'll see like 10 to the second power, 10 to the fourth, and so on and so forth, going up that side. Because obviously they're very big numbers and you wouldn't have the room you need to write all those down if you're trying to put all this on a one-page diagram. So, hope this helps. And like I said, you can find any information you need about a star, just use this diagram. Thank you so much. Goodbye.